Let me see about RNN, LSTM and GRU. We are going to use this algorithm for get the sentiment of the customer reviews. So here we are using RNN, LSTM and GRU. First we will see what is RNN. Here this RNN, it will get the information from the previous data and give us the output. Here this is the h, t minus 1 is the previous data, and it give use the using tan h, it gives the output. The output is th1. So this is uh, it have some short memory issues. To avoid the issues, we are going to use the LSTM. The LSTM means long short term memory. So it is use the previous data, use the sigmoid, and give the data. Then again use the sigmoid using tan h. It will find how much amount it can keep in the memory and send to the next stage. Then it will calculate the processing data with memory data. It will give the output. So to avoid the short memory in RNN, we use the LSTM. Then here I have one more algorithm, GRU. Here it don't have the memory, but it will using sigma. It will give the output. We can keep memory or not. We can this is um, we can forget or not. Then it will okay, based on the result it will reduce using minus subtrate from -1. These are the architecture we will use for sentiment analysis. Let me see the simple about or RNN. RNN means recurring neural network. It's designed to work with sequence data. It works with the sequence data. Sequence data can be time series, can be in format of text, audio, video. RNN use the previous information in the sequence to produce the current output. To understand this better, okay, we can see this. So my class is best class. Here, time. If we take the current time, the first step feed the word my in the network. Then RNA produce the output. At the time too, we have the already in the history my. Then second word, it will take the class, the activation function. So now RNA have the both my and class. If you see this one, it take my here to give the output, then it have the class, then it will give the output my class. It will come, but the problem is here short term memory. To avoid that, we are going to use the LSTM. If you see clearly in the PPT, we will see in the PPT first. So LSTM, RNN, LSTM, and GRU. So RNN means this is used for modeling sequence data. If you use for the sequence data, is good to for particular stage. Use for speech recognition, language translation, stock prediction, sequence. So it can use for the sequence data. Say if you like this. So here we will see. It will take the current, it will this is the input data. Here using this architecture, it will give the output, but it will take the feedback of the previous one. So what time is it? So it will take each the previous data has the one, then it will go take the time, then it will go is, then it will go it. So the previous data will go to vanish because of the short-term memory. So the current only have the give the priority in the RNN. See, now it have the full memory. See this color. Then you go here. It have the off. Then you go here. It will be reduced. What will be reduced? Then this memory will be increased. Once you go next, the what memory will be reduced. These have the highest see, as I said, what have here good memory. Then one is goes here next. This memory, the what information will be reduced. The current one have the highest memory. So this is because of short term memory. We cannot keep the history of the history data. So to avoid these issues, we are going to use the LSTM and GRU. So history first one. So it will work like this. Xt is the input. Then using sigmoid, it will say how much it have. If we take LSTM, it have the three layer. This is forgotten layer. This is the memory layer. This is the output layer. Okay. So when the go inside input go inside, it will say how much need to forget, how much remember. It will give only 0 and 1. Then same input will go here. It will say how much it will say how much forget remember. With this, it have the ct means using 10h. Ct means memory layer. It will say that something minus 1, 0.95, like this much can remember, this much can forget. Then this information will pass here. The same passing input information will pass here also. That will give the output. With this output, this will multiply. It will give the information as ht. Once ht, we can pass this as a input for the next layer again. Next input value, it will be like this. So because of the memory layer, it will remember the previous data. So here, this is the LSTM. So another one more, GRU. GRU is same like the RNN, but the one difference is we pass the using sigma, we pass the data. It will say how much forget, how much we can remember. This also has three layer: forget layer, update layer, and output layer. So here, once you pass the data using sigma, you can say the result, but with the result, it will subtract with -1. Then it give the result as ht. Then this is the output we received as ht. This will be go as a input for the next process as ht-1. So simply, as I discussed before, RNN is just get the input, then using and hatch passes the output, then it goes the input for the next layer. um, it will go like this, but it has a short memory. Due to this is simple architecture, good for speed. It is a less dense obvious suffer short memory. Because of these issues, we are going for LSTM. These are the memory storage. It will good for the longer sequence, which have the longer dependency. So, say, as I said, this is the LSTM have the three layer, forgotten gate, input gate, and output gate. This is the memory layer. We can say as input gate or memory gate. So, say, as I said, this is the forget or reset gate. This is the update gate. So we can. This is the um, three layers we are used because we are used in the find the sentiment analysis of the customer data. RNN, due to short memory issues, we go for LSTM and GRU. Uh, GRU same like this RNN, but it have a small extra option uh, to remember the previous data. So we will do now practical about RNN. So RNN, so we will see the pre-process about the data. Then we can use the um, movie data to find the sentiment. So RNN will import NumPy. Then this is the so then this is the data documents data. Here we import tokenization. With this token, we will pass a document in the tokenizer. Once we pass the data, why we keep nothing here? We if any other data will pass to check for the sentiment here for for all these words. There is an index will be formed. If there is, if we send any other words other than this, it will comes under the nothing. So we are further we are using nothing. So we pass the fit documents with the answer fit.text. If we need to see the index, we can use the word index. When we do this one, you can see the number here. So when you see the word count, it will show the related uh, index. When you see tokenizer, it have 11 text to sequence. So instead of text, we are going to see the sequence. See, um, this is the recurrent 7. Instead of recurrent, we keep the number as 7 here. So when you run this, it will come here. So when you pass this data in the CNN, it have the input layer. We need to define the input layer, then only it will work. Some of them have 3, some of them have 2, some of them have 5. To we need to make as equal to pass the um, to pass the input layer. For example, this is 1, this is 2, this is 3, 4, so 5. Yes, we need to pass. We need to define the input layer to pass this value. Like for example, 11, 12, 13, 14, 17, 4, 18, 5, 6. Here 17, here 4, 18, 5, 6. It will go like this. Okay. So now we get now we have only 3 to we need to equal all the values. To for that we going to add sequence. So import add sequence, then this one. When I do this one, it will go as 000. So like this we can do the pre-processing. For sentiment analysis, we will import the dataset from IMDb dataset. We can use a simple RNN embedding for create the layers. After import, so we get load the data here and pass split the data as train and test. Say now we get this is the train data. This which have because we have the sentence now change into this format. So the this one. Now we are take only 50 data in train and test for fast process. So this is the informations we have. So we are getting the model here. Model equal to sequential. Here we add the only one layer, simple RNN 32. 32 means this is the 32 data because of the short one. So input shape from we are using the multiple to single one. So we will make return sequence false because it will we no need to get return here. We will get the output layer here. So from here we will get the output using sigma. Because why we use sigma here, sigma we classify and give the value as 1 and or 2. Once we run this, so we will get this the architecture parameter. So when the model when we compile the model, in the compile we will add the binary loss optimizers add up, then we will find the metrics here, how much accuracy, how much metrics will become. So optimize for, we are using the Adam optimizer. Optimizer means what do you know, right? In the CNN, once we get the output based on the loss function, we will go back propagation. When the back propagation, we will use the optimizer. In this optimizer, it will update the weight and do the CNN steps as you change the weight and do the CNN process and give the loss function. So here we will do like this, then train and test, then we will find IVQ epoch 5. Now for testing, so the epoch is the um, it will iterate and give the value of accuracy and loss. So till that it will be run, we will see. Then we will use another embedding um, for the sentiment analysis. Same like this tokenizer sequence, take to sequence, same like this we are using here. Then instead of simple RNN, we use the embedding here. Embedding here, then we compile using added security. Then we use same embedding option. Here we are using both simple and NN, RNN and embedding. Then we will compile and fit the prediction, and in the prediction here we will get the output. This is the one. It is for if it's less than 0.5 it is the negative, greater than 0.5 it's a positive. So we can after what we can do after fit the model, we can go here. So what is it? Here we can get the data and predict. Okay, what we can see the result. So what the loss we get 0.69 and accuracy 0.5. So we get this one. This also, see, we can get the data as here. We get this data. So we will pass this data to the model. See, now we using the simple RNN, we get this much. So if it's less than 4, 5, this is the negative sentiment. If it's greater than 5, is a positive sentiment. So if it is like this, we can use, I can create the model using RNN. So another one, same way we can see in LSTM, same like that. We will import all the tokenizer embedding instead of simple RNN. We use LSTM here. Then load the uh, test and train data from IMDb dataset. Then we take this one. Then here instead of mm, simple RNN, we use the embedded. We use the LSTM here. Thousand. We use the take 1000 data. Then activation function is a sigma. Then we create the model. This one. Then which is a epoch 5 wake up wicked. So 5 epoch is created. Then this is model we we will predict the test data with model created one. Okay. Same. This resource I get from the iNeuron API. So thanks to them. So GRU, the as I said, this is GRU to remember the previous data. Same, we get the data and split the data. Then here, instead of see here, this is this place we use here LSTM, here RNN, simple RNN, simple simple. Here we implement simple reset. Hmm? A reset simple RNN here. Here we use GRU. Then all others are same. Then we can predict and get the result. So based on the result, we can see the review is positive or negative. So this is the practical to create the model and used in the sentiment analysis system. So, um, so this is the RNN. Again, as I conclude, RNN is a very simple one. It's a short-term memory, but with it keep only the few information. To avoid the short-term memory, we go for LSTM and GRU. It have more than this. It have power more than RNN, but it have only the previous data. But LSTM is the best one. It have the memory storage to keep the memory and give the result very fast. So this is the RNN, LSTM and GRU. Thank you.